G'day, how you going? And welcome to the 7th episode of Over the Moon, the podcast where I talk about all things space related, from the theories of creation to new rocket designs. Today we will be talking about Perseverance, the new Mars rover. Perseverance is a six-wheeled rover currently being designed by NASA to find possible past microbiological life on Mars. Perseverance is one of 5 Mars rovers. The first was Sojourner, along with the Pathfinder lander. The next was Spirit and Curiosity, about the same time, and finally Opportunity. Mars Perseverance will land at the Jezero crater, a location that can possibly house life or water. It will stay there and collect data for at least 1 Martian year. Perseverance is equipped with 6 wheels for movement. It also carries something called a MOXIE. The MOXIE is a Mars oxygen generator. It takes the carbon dioxide in the Martian atmosphere and then it turns it into breathable oxygen for humans. It's currently just proof of concept, which is why it will be launching to Mars on Perseverance, so they can actually see if it will work for future human flight. Perseverance is equipped with 6 different cameras on its movable head. It has 2 navigation cameras, 2 panoramic cameras, and a super zoom camera for close-up shots. Perseverance has a long arm equipped with something called a Sherlock and a Pixel. Sherlock is a camera that can detect extremely fine minerals and potential living organisms or signs of past life. Pixel is a super zoom camera that is capable of looking at super small objects on the ground and then taking pictures of it to send back to NASA. It is mounted on the turret, and due to that it can have a much bigger field of view as the turret arm thing can actually move around. There are also a few panoramic cameras in the back for that nice wheel mark shot. Perseverance can also pick up interesting minerals or rocks and put them into tubes. These tubes then stay there locked down for possible future missions to collect them or human missions to collect them, so they can then examine them further, just like the moon rocks. Perseverance is also equipped with RIMFAX. RIMFAX is an X-ray camera that can see through the surface of Mars. The reason they have RIMFAX there is to look under the surface of Mars and try and see if there's any frozen ice that can be potentially dug up to then be drunk by humans in a future human mission. Perseverance also has a weather sensor near its stomach. It can be used to detect the temperature or the dust levels during dust storms. There are multiple across the body and the interior. It can also detect any possible radiation in the Martian atmosphere to see how big the radiation problem will be for future human missions. It also detects how fast the winds are during the dust storms, as they're called, or sandstorms. Perseverance is also carrying a helicopter. The helicopter will be used to track a better path for Perseverance, as it's closer to the ground than the satellites that would usually be used. The helicopter's mission is planned to be for around 30 days. It could, however, last longer as Spirit, Curiosity and Opportunity also did. Why do SSTOs suck? On this That's the Reason segment of Over the Moon, we will be answering the question why SSTOs suck. SSTO stands for Single Stage to Orbit. SSTOs are rockets that have only one stage. It is just a payload, a fuselage, and then the engines. SSTOs are useful as you don't need as many moving pieces and nothing needs to be thrown off of a rocket, so there's less chance of failure. A regular rocket will have an engine and a fuselage or fuel tank. When that fuel tank is empty, it, along with the engine, is discarded. Doing this wastes the money of a fuselage and engine. SSTOs seek to save money by not discarding anything and keeping the entire rocket. One of the problems with not discarding any of this excess weight is the excess weight. You know, the rocket is trying to pull up already a large amount of weight, but then you just leave empty space there. So SSTOs carry around large areas, large empty fuselages. SSTOs need to somehow counteract this by using stronger engines or some other method. Another problem is the engine. Now, there are two different types of engines. There are aerospike engines and there are bell nozzle engines. Bell nozzle engines are the traditional rocket engine. They have two different forms. There is sea level engines and vacuum engines. Sea level engines are engines that are optimized to work in the Earth's atmosphere or at sea level. Sea level engines have a nozzle that's a specific diameter so as to work. If an engine, this is very technical, so I'm just going to skip over all the super technical parts, but very simply, if an engine is too wide or too narrow, the engine will just mess up and not work. Now, vacuum engines are engines optimized to work in space. You know, they're the exact right diameter so as not to fail. Now, aerospike engines work in a completely different and much more complicated way. They are able to work at both sea and vacuum levels, so most SSTOs use this. But aerospikes are more complicated and expensive, so aerospace companies end up using bell nozzles. Aerospike engines can be very useful, but as they are more technical and expensive, obviously they're not used as much, and instead you just discard part of a rocket. So, in conclusion, SSTOs suck because it's extremely hard to make them due to having to carry around so much excess weight and because they have to use much more complicated engines. That's the end of this episode. Next week we will be talking about the upcoming James Webb Telescope. I hope you enjoyed, and if you did, hit that like button and subscribe to see more content by me, and I will see you all next week.